Today, welcome to another series of Mathematics Just Got Easier with DR Tutors. In today's class, we are going to be considering the zeros of a polynomial, and in the next class, we are going to be solving questions on this. Pardon me, we have lots of notes on the board. We just want to have an introduction in this class. In the next class, we are going to take pure examples. So let's see what we got. The zeros of a polynomial are the x values where the function equals 0, that is, f as a function of x is equals to 0, and this is known as its root or x-intercept. For example, let's say we are plotting a graph now, and in the graph you have the x-axis and the y-axis. This is the y-axis and the x-axis. Now the x-intercept will be where the y-axis is equals to 0, and your y can also be taken as what? F as a function of x. So the x-intercept is where f as a function of x is equals to 0. And how do we find the zeros of a polynomial? We find the zeros of a polynomial by setting the polynomial function to 0. When we say f as a function of x is equals to 0, for example, we have f as a function of x is equals to x squared plus 4. Now, that is, we have to set the polynomial to 0. So in order to get the zeros of a polynomial, that is, you say x squared plus 4 is equals to 0. That is, you set f as a function of x to 0. This is what this simply means. And then, after setting the f as a function of x to 0, the polynomial to 0, you solve for x, often by factoring the polynomial into its linear factors, like x minus a or x minus a, x minus b. So the number of zeros relates to the polynomial's degrees, and each zero can have a multiplicity of 2. For example, when you talk about degree of a polynomial, let's say we have x minus 4 to the power of 2. The degree of the polynomial is what? 2. So the zero of this polynomial will be x equals to 4, and it has a multiplicity of what? Of 2. This is what this simply means. Now, so let's just quickly note this. Real zeros are where the x values, real zeros is the x values where the graph crosses or touches the x-axis. And we also have complex zeros. When you talk about complex zeros occur which involves taking the square root of a negative number. For example, if you have x squared plus 4, x squared plus 4 equals to 0. Now, you have x squared plus 4 equals to 0. Where you have x squared plus 4 is equals to 0. When you bring this here, you have x squared is equals to negative 4. Now we have to take the radical, the square root of this negative 4. And what does it do? It yields imaginary what? Zeros. We also have degree. Of course, we know that a polynomial of degree n has most real n what? Zeros. For example, what we said here, where we said x minus 4 to the power of 2. The degree is what? 2. Okay, so in the next class, we are going to take more examples on this to make it more clearer. Thank you for listening. See you in the next class.